Hello, calculus students. So today we are learning about antiderivatives and indefinite integration. So we've heard this word antiderivative before, and it's exactly what you think it means. So antiderivative is basically undoing a derivative. It's the process of undoing a derivative. Okay, and so we've heard this before in the context of integration. And we've learned that integration is kind of like finding the area between the curve and the x-axis. And we've had practice doing that, just looking at a graph and being able to know the area of a rectangle or area of a triangle to determine what the integral value is. But going forward, we're going to be looking at graphs that aren't so easy to find the area of. So for instance, if I have this weird function f of x, and I need to find the area, I don't know, right here, I can no longer just use basic geometric shapes like a rectangle. This isn't a rectangle, this isn't a triangle. I can't determine what that area is. And so that's when we're going to be using algebraic methods like antiderivatives. So basically this is going to help us find the area between the curves using more of a calculus method instead of using geometric methods. Okay, before we can do that though, we have to learn how to find antiderivatives. Okay, and so let's just focus on this one small step, finding antiderivatives, or what even an antiderivative is. So let's start reading right here. So suppose we have a function f whose derivative is given as big F prime equals f of x equals x squared. From your experience with finding derivatives, you might say that big F of x equals what? So let's try to figure out what big F equals, right? So we're going to use like a guess, check, revise method. We're going to come up with some guess, we'll check it, and then we might need to revise. And then in the end, we're going to smile because we love calculus. All right? So let's guess. Big F. I know that the derivative of big F is equal to x squared. So if the derivative is x squared, then maybe big F equals x cubed. Okay? That's just a guess based on what I know about derivatives. And so now we can check. The derivative of big F of x would then be 3x squared. So I'm close. I just want x squared. I have this extra 3. So this one's not correct. This isn't correct because I have this extra 3 value. But I'm really, really close. I'm on the right track. So what I need in my guess for big F of x, I still think I need x cubed. But I need to put something in front so that when I bring the 3 down using the power rule, it goes away. So I need a number out front that will kind of cancel out that 3. And many of you are probably saying what it is. It's 1/3. So if I put 1/3 there, and then I find f, the derivative of big F, the 1/3 cancels out with the 3, and I'm just left with x squared, which is what I wanted. Yay! Smile. But this is just an antiderivative. That's what it says here. Congratulations, you have found an antiderivative, meaning there are more antiderivatives. And it's a little tricky, so I'm going to show you. We still want to keep this like 1/3 x cubed going on. But what happens when I add a 2? If I add 2, the derivative of big F of x, the 1/3 and 3 cancel out, and I'm left with x squared. The derivative of 2 is 0. So that works too. Yay! And that would work even if I put 12. The derivative of 12 is still 0. Or 124. The derivative of that is still 0. So no matter what kind of constant I add here, all of these work as being an antiderivative to x squared. And so that's why we get this definition here. So big F is an antiderivative of f on an interval if f prime of if the derivative of big F equals f. So both of these f's that I came up with, both of them have a derivative of x squared, so both of them are antiderivatives of x squared. All right, okay. So here on this line, they give us a whole bunch of the possible different antiderivatives. And all of them are graphed at this point right here. Okay? And the reason why I know why they're antiderivatives is I could draw a tangent line. Like, let's see, I draw a tangent line right here for this x value. We'll call this x value c. Then I know f prime of c has this slope. There's my tangent line. So that's my tangent line, f prime of c, my tangent. But I could shift this tangent line up. And if I shift it directly up, hello, I'm trying to move you. Copy. Well, whatever. But if I were to move this thing up, I would have the same tangent line like right here. Oh God, that's not a parallel line. So at C, at this value C, they all have the same tangent line. That's just been shifted. It's just been shifted up. Okay, so this question in bold asks, what graphical consequences does the plus C have on the solution curves? So adding all these different constants is literally just a vertical shift. So all of the antiderivatives basically look the same. They're just vertically shifted up or down depending on what the constant is. Okay. So a little bit of notation that I want to introduce is this big F. We've looked at it a little bit. But basically all of these are related, like going down. I'm gonna change up my colors. Beautiful green. So going down to each of these, the way that we go down this ladder is by taking our derivative. So to go down, we take the derivative. And then the way to go back up the ladder, red. Now we have this word to describe what's happening is we take the antiderivative. So if I had f double prime, in order to find f prime, I would take the antiderivative. And if I have f prime, the way that I get to f is by taking the antiderivative. And then the way to get from f to big F is the antiderivative. Okay, so these are all, this is pretty much all the functions that we're going to learn about in calculus. I don't think I'll surprise you again introducing a new type of f. That's what we've got so far. And then a little bit of notation about how we would use the integral symbol with this is kind of like what we showed above. I'll use my green to show the derivative. So when I take the derivative of big F of x, as we saw before, we would say f of x equals x squared. So that's when I take the derivative of big F. And then going back to my red, the way we would go backwards is if I have, to get big F, we would take the integral. This is the indefinite integral of f of x. And that equals 1/3 x cubed plus the c. And so this plus c is just it's called the general equation for the antiderivative, and this kind of encompasses all of the possible antiderivatives. So plus c means it's all of the antiderivatives. It could be, c could be any constant, and it represents all of them. Okay, so this is how we use the integral symbol. When you see that, what you're doing is taking an antiderivative. Okay, so using this method that we used up here, this guess, check, repeat, guess, check, revise, that's going to get complicated when we start having different equations, like you can see in example 1. So in the next video, I'm going to show you a strategy for finding antiderivatives.